Hello, welcome to this lesson of second order PDE. So, if this is your first time of watching a video on my channel, kindly subscribe. Okay, alright, let's start. So, in our last discussion, I said that if you have second order PDE of this form that has everything, how do you solve it? Okay, so what you first have to do is, first of all, you find b squared minus 4ac. And in our first discussion, I said, or in our first lesson of this, I said that you have to classify this PDE based on the solution you get here using the b squared minus 4ac. If it is less than 0, you know what you say. If it is greater than 0, you know what to say. If it is equal to 0, you know what to say. Okay, and then you come and solve this characteristic equation. Okay, you come and solve this, and you see that with the plus or minus here, so far as b squared minus 4ac, or let's say, let me, okay, 4ac, so far as it is not equal to 0, always this will generate two different solutions. Okay, because if I take only the plus side, I'll get a different solution. If I take the minus side, I'll get a different solution. So far as the b squared minus 4ac is not equal to 0, but when it is equal to 0, then I will get only b over 2a. Okay, and with that, I'll tell you how to get another function to characterize this PDE. Okay, sometimes the b squared minus 4ac will be less than 0. That one will be in a complex form, and then also in our next discussion we'll talk about it, how to go about it when you have a complex form. Okay, all right, so let's move on and take examples and discuss on how to go about these. All right, so with this we have a first discussion to go about that. If you have y squared uxx minus 2xy uxy like this, how do I solve it? Okay, so what you have to do is you compare with the previous one. Okay, a is the coefficient of uxx, b is the coefficient of usy, c is the coefficient of uyy. Okay, so what you do is a is equal to what? Y squared. B is equal to minus 2xy, and c is equal to what? S squared. Okay, now with this, sometimes you can even bring the right hand side of the equation to the other side of the equation. Okay, you can do that, but if you can see like I'm seeing here, that is also fine. Okay, so before we discuss this, let's bring it down here, or bring it to the left side, so that the equation becomes simple. Okay, so now this equation is the same as y squared uxx minus 2xy uxy plus s squared uyy. This is equal to, if I multiply 1 over xy through, I'll get y squared over x ux plus s squared over y uy. Okay, now if I try to simplify or bring them back here, I'll get something like this: uxy plus s squared uy y minus y squared over x ux minus s squared over y uy equals 0. Okay, so this is a general form that we've simplified our question into. But you know that a is that, b is this, and c is also that. So now we said that we find b squared minus 4ac. Okay, so for b squared minus 4ac, and this is equal to minus 2s squared, or 2xy, let me put it that way, 2sy squared minus 4, a is what? Y squared. Okay, and b is s squared. Now we get something like 4s squared y squared minus 4s squared y squared, and this is equal to 0. Okay, and we said that if your b squared minus 4ac is equal to 0, then what you do is you say that the equation is what? Parabolic. So this whole equation, or this whole PD, is parabolic in nature. Okay, Now, knowing this, we have to solve this characteristic equation. dy dx equals b plus or minus square root of, okay, b squared minus 4ac over 2a, and b is what? Minus 2xy. We have a, we have c, so we know that b squared minus 4ac is 0. So this part of the equation, or this part inside the square root will go. Okay, so I have this is equal to b is minus 2xy, then over 2a, and a is what? I have a to be y squared. Okay, this is the same as minus x over y. Okay, I hope you can see this. 2 will take this, one of the y will cancel one of the y down, then you have minus x over y. So I have dy dx here being equal to minus x over y, and this implies that we have separable ODE. Okay, so I have y dy is equal to minus x dx. Okay, so now with this, let me use a white pen for you. Okay, so I have 1 over 2 y squared is equal to negative 1 over 2 x squared plus some constant, but here let's call the constant real, or any letter. Okay, so you can call it nu or mu or anyhow, but let me call it real. Okay, so my real here, if I multiply 2 by 2, I'll get y squared equals negative x squared plus 2 real, and it's the same as a constant, so I still call it real. So I have real being equal to x squared plus y squared. So this is one of the characteristic equations that will characterize this PDE. Okay, the PDE game. Now, since we have b squared minus 4ac being equal to, that means we have only one characteristic equation, and then you choose another characteristic equation. You say that tau should be also equal to x. In our discussion in the first order PDE, we said that this will always characterize a PDE. Okay, so we have two different way of finding our, how do we call it? We have two different functions that characterizes this PDE. Okay, so what you have to do is you have to come back to the PDE, knowing perfectly well that I have real is equal to that, tau is equal to that. I hope you can also go through that same process and find everything. Okay, so what we are coming to do is write our real, whatever that we want to write. Okay, let me write it here. We say that real is equal to x squared plus y squared. That is one of the equations that characterizes PDE. We have tau is equal to x. So once we have this, all I have to come and do is find your uxx in terms of real and tau, uxy in terms of real and tau, uyy, like that, ux, uy. You do all of these, and then you try to, simplify, and then we'll turn everything down to a very simpler PDE for us to solve. Okay, so this is what you do. You know that our real is equal to x squared plus y squared. Okay, now tau is equal to x, so keep this in mind. Now ux is the same as del u del real. Okay, then times del real del x. Okay, del x plus del u del tau times del tau del x, and this is equal to del u del x is 2x, so I have 2x, then u real plus u tau. Okay, so that is ux. Now you have to find uxx. Uxx is equal to del x of this whole thing. Okay, so 2x u real plus u tau, and this will give us, you see, it should be del x. Let me go through them step by step. 2x u real plus del x of u tau. Okay. Now with this here you have two product functions because you have 2x which is in terms of x, and the u real is a derivative with respect to real, but then we assume that the final answer will be in terms of x and y. Okay, since real also depends on x and y. So you have first you differentiate everything with respect to x. Differentiate 2x here, okay, and you keep this. So what you get is you get 2, okay. Then we keep the u real, then plus with the first term, this term, then plus you keep 2x, then del x of u real plus. Now this is the same as del x, okay, of u tau is del tau. That is how we mean. Now this is equal to 2u real, okay, plus 2x, okay, 2x, and we have 2x, and we have 2 differential, but let me open it. So del x into del u del real plus del x del u del tau. Okay, these are what we have here, and I'm coming to use something called a Clairaut's rule that says that if I have these two differentials, okay, something like these two, this and this, I can do the differentials interchangeably. Okay, what I can do is that I can simply first, okay, let me write the first term plus 2x, then I can write del real. I can do the del x first, okay, times del x. Okay, I can interchange the denominators, and del x, sorry, del u del x is the same as ux, okay, plus del tau of ux. Okay, now what is our ux? We go back and check our ux. Our ux is what? 2s u real plus u tau. Okay, so you come back and put it here. Okay, come back and put it in this. This is equal to 2u real plus 2x. Then we have del real of 2x u real plus u tau plus del tau of the same thing here. Okay, let me do it here. Del tau of u 2x u real plus u tau. Okay, now that we have this, we can do the differentiation very easy. Okay, this will give me 2u real plus 2x times, okay, if I differentiate the whole of this with respect to real, I'll get 2x u real since there is a u real already here plus u real tau. Okay, now plus 2x u real tau plus u tau. Okay, so in effect we have uxx being equal to 2u real plus 4s squared, okay, 4s squared u real plus 2x u real tau plus another 2x u real tau plus u tau, and then at the end this is what we will get. Uxx here is now equal to 2u real plus 4s squared u real plus 4x u real tau plus u tau. Okay, so this is what we have for uxx. Okay, so we can go ahead and put it in the solution, the 2u real plus 4x squared u real Okay, so let me go and then put it back here. Alright, so kindly just go through them. Okay, you can do them on your own when you have time. Okay, so that when you meet it anywhere you'll be able to do it. So u we have 2u real plus 4x squared u real plus 4xy. Is it 4xy or 4x? I think it's 4x, right? So 4x u real tau plus u tau tau. Okay, let's go and check if whatever we've written is correct. So we have that's so that you go and find our u. Okay, I hope everything is correct. Isn't that okay? So you go ahead and then find u x. Okay, you go ahead and find our okay. This is what we need. Okay, this is what you need. Okay, so we just have to take note of these. This one, okay, which is a ux. This is uxx. Okay, in terms of tau and real. So keep them in mind. Now we go to the next one. What we have to do is we find our u y. This is equal to del u del real dot del real del y plus del u del tau dot del tau del y. And now you know that tau is equal to x. Okay, so it depends on only x. So del tau del y is 0. So it makes this place 0. And now real is also equal to x squared plus y squared. So if I differentiate with respect to y, I get 2y u real. Okay, so this is for uy. And now uyy is also equal to del y of uy. Okay, so we have 2y u real. And this will be equal to now product through the same thing that we did for the 2x u real. You differentiate everything with respect to only the 2y with respect to y. You get 2 then times u real plus differentiate this, so it becomes 2y del y of u real. So now my uyy is equal to 2u real plus 2y then del real. Okay, we are interchanging them times uy like we did. So this is equal to 2u real plus 2y del real of uy, which is 2y u real. And this will give me, this is very simple. Okay, so this will give me 2u real plus 2y squared, or sorry, 4y squared. Let me write it well. 4y squared u real. Okay, so now the only thing we have to find is find uxy. So we have 2u real plus 4y squared u real. Okay, so let me write my uyy here. Okay, so that when you are coming for it, it will be very simpler for us to get. Okay, my uyy is now giving us 2u real plus 4y squared. Okay, u real. So let's keep this and go for uxy. Okay, our uxy, okay, is equal to, is the same as del x of uy. Okay, this is the same as del x of, now uy is giving us what, coming here, uy is 2y u real. Okay, so it becomes 2y u real. Okay, this will be equal to Now there is no x in terms of the 2y. Okay, so 2y becomes a constant in this differentiation. So I have 2y del x of u real. Okay, this will give me 2y del real of ux. Okay, and what was ux? So I have 2y del real of, now ux is given as this. This is my ux, 2x u real plus u tau. Okay, so I'll go to the next one, 2x u real plus u tau. Now I'll get 2y into 2x u real plus u real tau, or tau real, anyhow you want to call it. They are the same. Okay, so I have my xy being equal to, sorry, I have to multiply this. So I have 4xy u real plus 2y u real tau to be that. Okay, so for xy, let me write it somewhere. Okay, so I have it here. Let me write it. I hope you can go through how we derive the formulas, or we derive the derivatives. For xy u plus 2y u tau. So we have every term in our PDE. Okay, if you go to the previous one, the question is like this. Okay, if you go through the question, you see that this is a question. Okay, and we made sure that we've simplified it to this form. Okay, this form. And so we are coming to put everything back in this equation. Okay, so we have y squared times uxx. So we go, okay, we go to the next slide and write y squared times uxs, and uxs is given as what? So we go to the previous one, and uxs is given as 2u real, this one. Okay, let me use the red pen for you to see this one. 2u real plus 4x squared u real plus 4x u real tau plus u tau tau. Okay, so let me do it one by one. So 2u real plus 4x squared u real plus 4x, that's okay. Now before we put everything, let's write the equation. But the equation looks like this: y squared, okay, let me change the color, y squared uxx minus 2xy uyy, or uxy, sorry, plus s squared uyy, okay, minus y squared over x ux minus s squared over y uy equals 0. This is how we simplify the equation to get. And now if I put everything back, okay, my equation will be like this. Wherever I see uxs, I put it there in terms of what we've gotten. Okay, so I have y squared into, now I have 4x squared u real plus 4x u real tau, okay, now plus u tau tau, okay, plus 2u real. That's only for uxs minus 2xy, and uxy is 4xy u real plus 2y u real tau. Okay, I hope, let's go to the previous and see. 4xy u real plus 2y u real tau. This is what we had indeed. Now plus, okay, so plus, we have s squared here into uyy, and then the uyy was given as what? 2u real plus 4y squared u real minus y squared into u over x into ux, and ux is given as what? 2x u real minus, sorry, plus u tau, okay, then minus s squared over y 2y u real, and this is equal to 0. Okay, so you have to simplify everything here that we have. Okay, now if I do some multiplication here, you can see that we have 4 s squared y squared, so we have 4 s squared y squared here, u real, okay, plus 4xy squared u real tau plus, now what do I have here? 4, so it's y squared, right? Okay, y squared u tau. I have plus 2y squared u real. Okay, now minus 2xy, or let me see, when I multiply them I'll get minus 8, right? Minus 8s squared y squared, okay, u real, then minus 4xy squared, okay, is it minus 4? Yeah, 4 minus 4xy squared u real tau. Okay, now you have to go to plus, but I have to move it up there for us to continue. So we are just going to the next one. Okay, let me use the same thing for simplification sake. Okay, so we are coming to this. There's a plus here, so plus everything that is here. So I have plus. Now the first one will be 2s squared u real, so 2s squared u real, then plus 4s squared y squared u real minus, now I have this x can take this off when I'm multiplying them, so I'll be left with 2, is it 2? I have minus 2 y squared, okay, u real, right, 2y squared u real, then minus y squared, okay, is it y squared, okay, I'll put it this way, y squared over x u tau, okay, I hope that is correct. Then okay, let's move on. You have the last part minus the last part, okay. I hope you are following. So the last part is minus, how do I call it? I have 2s squared u real. Now this is very, very tedious, right? But let's follow so that in case you meet any second order PD, you'll be able to solve it. Now let me use some colors for some of them. When you compare the u real, you see that we have 4s squared u real and another 4s squared u. When I add them, I'll get 8s squared y squared u. Okay, and I add these two, I'll get 8s squared y squared u. But I have minus 8s squared y squared u here, so they will cancel this off. Okay, now when I come to the xy sy squared, okay, this term with a real u real tau, okay, we see that I have 4 of them here Then I have another 4 of them here. So they are gone. These two will cancel themselves and they will gone. Now when I come to u real, okay, when I come to u real, I have, or let me say u tau tau. When I compare the u tau tau, this is the only u tau tau I have. Okay, let me underline it. And so I don't have to do anything to it. Now when I come to the u real, I have 2y squared u real here. I have minus 2y squared u real here. So they will go. When I come to 2, I have another 2, sorry, I have another u real here in term of this. Okay, so let me find it out. Where did I put that one? Okay, where did I put that one? I have 2s squared, some 2s squared u real somewhere. Where is it? Okay, this one. So I have this 2s squared. That's the last part. So you see that this equation, since it was plenty, everything is equal to 0. So let's keep that one in mind. So I have this last part here. This one can take this off. So in effect, you can see that this is being cancelled. This is also being cancelled. This is being cancelled. This is being cancelled. This is also being cancelled. This is cancelled. This is cancelled. And this is also cancelled. So you are left with only 2 terms. Okay. That is this term and this term. So we come back here. Okay. We come back and write our PDE like this. Now my final PDE will be in terms of this y squared u tau tau, okay, minus y squared over x u tau is equal to 0. You see that this is very simple, but it was very long. It was really long. So you could see that if I divide through by y squared, if I divide everything here by y squared, I get u tau tau minus 1 over x u tau, and this is equal to 0. But if you remember, we said that tau is equal to x is one of the characteristic equations. So I have u tau tau minus 1 over tau u tau is equal to 0. And this here will now be my simple PDE for me to solve, since I have only one term here. Okay. Now with the coefficients here, the coefficient here will restrict us from using u of something is equal to e to the power. Other than that, I would have used that one and go. But we have a coefficient in terms of variables, so we have to be careful about this. Okay, so let's come here. Know that our u, we have u tau tau minus 1 over tau u tau is equal to 0. You can simply use integrating factor, but then before you have to do some substitution. So we let u tau be equal to some v. And so since we have double tau here in place of the first one, we'll get v tau minus 1 over tau v is equal to 0. And now we'll be able to solve this. So the integrating factor for this, only this one, is e to the integral of negative 1 over tau d tau. This is equal to e to the negative ln of tau. This will give me e to the ln of, since I'm having logarithm here, so I can use some logarithmic properties here. So I have e to the ln of 1 over tau, okay, and this will give me e to the ln of anything is the same thing in the brackets from logarithmic property. Okay, so this will give me 1 over tau. This property is from logarithm, so the integrating factor here if is 1 over tau. Now let's do some movement. Let's move it up and solve it very simple like that. So once you have an integrating factor, you know that you can multiply your integrating factor through your equation. I have 1 over tau squared v. When I multiply it through, I'll get that. So this is the same as d tau of 1 over tau v. So this is v tau. There's supposed to be some tau here. Okay, let's then equals 0. So here, same thing like we do always. Okay, this has become very simple for us to solve. So I have d of 1 over tau v equals 0 d tau. So if I integrate both sides with their respective variables, I'll get 1 over tau v is equal to some f of real. We are dealing with tau in real, okay? So v is equal to tau f of real. And now I have to continue with this, but we said that v is equal to u tau, okay? So it means that, but v is equal to u tau. So I have u tau here, okay, u tau here being equal to tau f of real. So if I integrate both sides with respect to tau, I get u of real tau being equal to 1 over 2 tau squared f of real plus capital F of real, since, or let's say g of real, another constant in terms of real, since we actually have how do I call it, we have a first, or we have initial constant in terms of real present here, okay? So this, the solution of this in terms of x and y is equal to 1 over 2 tau is x, so I have s squared, then f of, sorry, let me do this, s squared, then f of real is what, s squared plus y squared plus g of s squared plus y squared, okay? I hope you understood everything that we did. So this is a solution to the PDE given in the question for us to solve. So this is the final solution. So if we have initial conditions, we can find particular solution. So let's go ahead and solve this question as well, okay? You can go through the same thing. It's the same process that we pass through. Okay, so first of all, what we do is, first we said we solve dy. Let's check for its classification. Okay, you know that a is equal to 1, the coefficient of uss, and b is equal to the coefficient of usy, which is 1. C is equal to the coefficient of uyy, and that is what, negative 2. So b squared minus 4ac is equal to 1 squared minus 4 into a is 1, okay, c is negative 2, so I have 1 plus 4 times 2, which is 8. I hope you can see that, and this is 9, okay. So we have this greater than 0, and this is what, b squared minus 4ac here is greater than 0. So we have a hyperbolic equation. Since we are using b squared minus 4ac, we said that when it is less than 0, we have elliptic. When it is equal to 0, we have what, parabolic, and when it is greater than 0, we have hyperbolic. Okay, so if you are using the determinant formula, it's different. Okay, so let's quickly go through how to solve this. Now we said you solve this, dy dx here is equal to minus b. Okay, so plus or minus the square root of b squared minus 4ac. Sorry, there shouldn't be any minus b. That is one thing you should know. I even made a mistake. Most students make that mistake, that they quote it as the same as the quadratic formula, but here there is no minus b. Okay, so b plus or minus this over 2a, and this should be equal to b is what, 1 plus or minus the square root of 9. Since we've already calculated for it, the b squared minus 4ac all over 2 times 1. Okay, now I have 1 over 2 plus or minus square root of 9 is 3 over 2. So this is the y dx. And if you remember, I first said that once this part is not 0, you always get two different solutions. So now if I consider the first part, okay, if I consider the first part of the equation, I have the y dx. Let me use another pen for it, okay. Let's use a blue pen. The y dx equals, I have half plus 3 over 2. This is equal to 4 over 2. And this is 2. So it means I'll have something like dy dx is equal to 2. And so dy is equal to 2 dx. So I have y is equal to 2x plus some constant real. And if I do my simplification correctly, I'll have y minus 2x is equal to real. If I divide through by negative, I'll have negative y. So I have 2x. Okay, I have 2x minus y is equal to negative real, which is still a constant. So I have my real to be this. Okay. And now when I go to the other side, okay, with the same dy dx equals half plus or minus that. So if I consider the other side, like dy dx is equal to half minus 3 over 2, I get negative 1. I'll have minus 2 over 2, which is negative 1. Okay, so dy is equal to negative dx, and it means that y is equal to minus x plus some constant tau. Okay, this means that I have x plus y is equal to tau. So this is simply my two characteristic equation to characterize my PDE. Okay, so let's keep them. All right. Okay, so let's go to the next slide. We said that real is equal to, go to the previous one and see. Sorry, we have real is equal to what, 2x minus y. Okay, so we go to that and write 2x minus y, and my tau is equal to x plus y. Now if I have this, what is my uxx and what is my ux? So I have, simply let me use a different color for them. My ux is equal to del u del real times del real del x, okay, plus del u del tau, okay, times del tau del x, okay. And this will give me 2 u real plus u tau. So uxx will simply be equal to del x of 2 u real plus u tau. And since there is no product of here, there's no x inside this, I have only 2 del x u real plus del x u tau. So like we did for the first one, just interchange them. So I have 2 del real of ux plus del tau of ux. Okay. So simply this will be equal to, okay, this will be equal to 2 del real of ux is what, 2 u real plus u tau plus del tau of ux, and ux is still 2 u real plus u tau. Okay, so let me go ahead and push this up. So now I have uxx equals 2 times, now if I do this, I'll have 2 u real plus u real tau plus 2 u real tau plus u tau tau. So I have something like this: 4u real plus 2u real tau plus 2u real tau plus u tau tau. This is equal to 4u real plus 4u real tau plus u tau tau. So we can go ahead and write it at the top there so that when we come for it, it will be very easier for us. Okay, 4u real plus 4u real tau plus u tau tau. Now let me clean it. Then I know you understand the process since we've done it. Sorry, I actually don't have to do it this way. I think it's this part that I have to clean. Okay, so we have let me take another color. 4u real plus 4 u real tau plus u tau tau. Now this is what we have. Okay, so I hope you've written the correct one. Okay, this is supposed to be real tau tau. I hope everything is okay. Now let's move on to RU, XY, and RU, YY, and the rest. Okay, so my UY is simply equal to del U del real dot del real del Y plus del U del tau dot del tau del Y. Now UY, let me write it here, is equal to, and you go back to our previous listing and see. Now this is tau. Okay, this is tau, this one, and this is real. Del real del Y is -1. Del tau del Y is 1. Okay, so you go to that and we have -u real plus u tau. Now uyy will now be equal to del y of uy. Okay, and this is equal to del y of -u real, okay, plus u tau. Okay, so now this is equal to negative del real. I'm changing them straight away, and I believe you understand. Plus del tau of uy. Okay, and this will be equal to negative del real. Now uy is what? Negative u real plus u tau plus del tau, okay, of negative u real plus u tau. Now with this one, you can simply do it. Okay, so this is equal to negative times negative. So I have positive. So I have u real plus, sorry, it should be minus rather, minus u real tau and minus u real tau and plus u tau tau. So I have u real minus 2u real tau plus u tau tau. So u real minus 2u real tau plus u tau tau, that is for uyy. Okay, so let me clean here and then write it. Okay, I hope you understand what we are doing here. It's very, very cool, very, very simple. Okay, so u real, sorry, u real minus 2u real tau plus u tau tau. Okay, u tau tau. So let's go ahead and find for uxy. Okay, so uxy, sorry, uxy is actually equal to del del y of ux, okay, or del x of ui. Let me put it that way. X of ui. Anyhow you do it, it will go. And ui is what? Del x of. And I go to the previous one. Ui is this. Okay. Minus u plus u tau. Okay. So that is ui. So we come and put ui there. Minus u plus u tau. Okay. So minus u plus u tau. And so this will give me negative del real of ux. I'm interchanging them. I hope you understand it as it stands so far. Del tau ux. We said that this and this you can interchange them. Okay. Alright, so what is our us? So minus del real. Now ux is what? Go to the previous slice. See that ux is 2u real plus u tau. 2u real plus u tau. So I have 2u real plus u tau. Okay. Now plus del tau of 2u real plus u tau. And now this will give me negative 2u real minus minus u real tau. Okay. Then plus 2u real tau. Okay, plus u tau tau. This is equal to minus 2u real plus u real tau plus u tau tau. Okay, so I go ahead and then put my this thing in. Okay, let me write it at this part here so that it wouldn't be difficult for us when we are finding the back. Okay, oh, this is it, just the answer. Okay, so we'll go ahead and then write our equation back in our next slide. Okay, so this is what we have the equation was given us uxx plus uxy minus 2uyy plus 1 equals 0. So I have to put my equation, my here, my everything back. So go to the previous slide and find uxx there. Okay, so uxx was given as this. So it's 4u real plus 4u real tau plus u tau tau. Okay, we have 4. Let me use a different color for it. 4u real. Okay, plus 4u real tau plus u tau tau. That is for only this. Now I go ahead and find uxy. Uxy was just given as this one. Okay, so we just have to pick it here. So minus 2u real plus u real tau plus u tau tau. So I have minus 2. So let me actually clean the first one here. Okay, and get our minus 2. So minus 2u real plus u real tau plus u tau tau. Okay, then minus 2 into uyy. and uyy was given as also this u real minus 2 u real tau plus u tau tau. Okay, so you have u real minus 2 u real tau plus u tau tau plus 1 equals 0. So we simplify that. I have 4u real plus 4u real tau, okay, then plus u tau tau minus 2u real plus u real tau, okay, plus u tau tau minus, if I multiply 2 through this, I'll get 2u real minus that, have plus 4u real tau and minus 2u tau tau plus 1 equals 0. Okay, so now all that I have to do is find some cancellations and do. Okay, so I have 4u real. Now I have two of them here, so 2 will go. I have another minus 2 here, so the 4u, this, they are gone. Okay, so I have u tau tau. Okay, and we have 2u tau tau here. Okay, one of them is this, and one of this, so I have 2. Okay, I have minus 2 of that here. Okay, so what I'm left with is only the u real tau, u real tau. Okay, I hope everything is correct here. I hope everything is correct. Okay, so with this, I have 4u real tau, another one u real tau, then 4u real tau. I have 9 of them. Okay, I just want to look through it. I don't want to make any mistake here. Okay, so I have 9 u real tau plus 1 equals 0. Okay, so all that I have to do is just so like I said, we see that we have only the, sorry, let me use another color. We have only the u real tau, u real tau, u real tau here. Okay, so I have 9 of them, 4 plus 1 plus 4. So we have 9 u real tau. Okay, let me erase and write it well. Okay, plus 1 is equal to 0. Okay, so I have u real tau minus 1 over 9 equals 0. And this implies that we have our simple equation to be u real tau is equal to, sorry, it should be plus here, negative 1 over 9. Okay, so now with this, how do I go about it? This is a constant. Okay, you can solve it with the previous one that we did. Okay, you can substitute u tau or u real by something, just straight out like that. Okay, so we can let let's say u real be equal to v. So it means that u real tau will be equal to v tau. Okay, so I have v tau being equal to negative 1 over 9. Okay, so I integrate both sides with respect to tau, and I'll get, let me do it here. I'll get v is equal to negative 1 over 9. Okay, then some tau. Okay, some tau plus some constant, say f of s. Okay, is it, there's no, we have this tau in real, so I have real. Okay, but v is equal to u real, so I have u real being equal to negative 1 over 9 tau plus f of real. So if I integrate both sides with respect to real, I'll get u of tau, then or u of real tau, let me put it that way. U of real tau being equal to -1/9 real tau. Okay. Since we are integrating with respect to real, tau is a constant, and plus some capital F of real. Since we have f of real, when you integrate with f of real, you get another function in terms of real. Okay. So I have that. This means that my u of xy is now equal to -1/9. Now my real is what? My real is 2x minus y. Okay, that's what we had. And my tau is x plus y and plus f of real, which is 2x minus y. Okay. All you get is if let's say with the v equals u real, if we did it the other way, that v equals u tau, maybe you might got a different answer. But when you are being given what we call the initial condition, we'll be able to find the same answer. We'll be able to get the same answers. The only part that might change will be this side. Okay, when you have initial conditions, or when you change the u equals or u real equals v, that's what we first did. If you had done it like u or v equals u tau, this part would have changed to some tau of something or some g of something. Okay, but mind you, the answers will be the same. Once we have initial conditions, we'll be able to get the same answers. Okay, so this is how you solve for any form of second order PDE. I hope you can relate to that. When you have a part as in the b square minus 4ac where it is equal to, let's say if you have, let me see, when you have a part where you have b squared minus 4ac less than 0, then you are in a complex zone. You know how to deal with complex numbers as well. Okay, so thank you, and don't forget to subscribe to my channel. In another discussion, we'll talk about the wave equation and then take heat equation and probably the Laplace equation. Okay, thank you, and don't forget to subscribe to my